As we age, the tiniest blood vessels in our bodies wither and die, reducing the blood flow to organs and tissues. Vascular aging causes many diseases: cardiovascular, neurological, muscle wasting, frailty, and even aging. Here at Harvard Medical School, we've reversed this process in mice, setting the stage for radical new therapies to help people. The new study has unraveled the cascade of interactions between blood vessels and muscles. Endothelial cells, which line the walls of blood vessels, are essential for the health and growth of the vessels. And as endothelial cells age, blood vessels begin to atrophy and die. Blood flow to many parts of the body diminishes. Organs and tissues begin to function less well. Blood vessel demise hits muscles especially hard, because muscles rely on a robust supply of blood for their function. This process can be slowed down with regular exercise, but only up to a point. Over time, even exercise fails to stave off blood vessel demise and muscle loss. The new findings have cracked the mystery behind this process. As our blood vessels age, they become deaf to the signals from exercised muscle. This actually leads to the muscle shrinking as we get older, and therefore we're less able to exercise and grow new blood vessels. A vicious cycle indeed. The two key players in the crosstalk between blood vessels and muscles are a molecule called NAD and a protein called SIRT1. NAD boosts SIRT1, which in turn enables the conversation between muscles and blood vessels. But both NAD and SIRT1 decline as we age. They can no longer perform their role as the interface between the muscles and blood vessels. In our new study, we gave mice NMN, a chemical compound commonly found in the body and previously shown to boost NAD levels, which in turn boosts SIRT1. These mice had better endothelial function, blood vessel growth, and improved blood supply to their muscles. And what was most striking? These animals' capacity for exercise improved dramatically. In fact, the old mice treated with NMN had up to 80% greater exercise capacity compared with the untreated old mice. These results, I believe, can help millions of people who have lost their mobility or simply can no longer exercise, either through frailty, disability, or old age. This sets the stage for new medicines that will be able to restore blood flow in organs that have lost it, either through a heart attack, a stroke, or even in patients with dementia.